Hello guys. In this video, we are going to discuss about, I'm going to explain you guys about the variations in the stack organization. If you can see here, the stack is from 4001 to 3000, right? So initially, this is the first element of the stack. Let us consider that this is the base of the stack. This is the base of the stack, and the final location of the stack is 3000, right? But in the register stack, base of the stack is 0, and the final element of the stack is 15th element, right? So when you increment 15, 15 plus 1 is equal to 0. In the previous video, we discussed why 15 plus 1 is equal to 16. That is, 15 is equal to 4 ones. Again, let me write to make it more clear. 15 plus 1 is equal to 1, 0, 0, 0, 0. But stack pointer is of just 4 bits. Okay, stack pointer is of just 4 bits. It only take these least significant 4 digits, and the stack pointer will come back here, right? Stack pointer will come back here. But in the memory stack, what is happening? If a stack pointer reaches to the final element of the stack, that is 3000, I mean, if you want to, decrement even more further, what will happen? You will go to 2999, which is not a part of a stack. So at that time, there will be a problem. You are crossing the limits of the stack. When you cross the limits of the stack, it will be a biggest problem, because all the stack operation should be confined to the stack itself, should be confined and performed within the stack, all the stack operations. So the final element should be pushed here. The first element will be pushed here, second element, third element, fourth element, fifth element. You have seen in the register stack. Once the stack pointer gets updated here, then element will be pushed. Finally, when the stack pointer shows 3000, there is an element. Here there is an element. And now the final element should be pushed here, not in 2999. 2999 is not a part of a stack. It's not stack. Okay. So what we should do is, in the register stack, we did not get this problem because the register stack is just the stack, and when it goes to the final position, if we increment it more, we will come back to, if we update it more, we will come back to the base of the stack, right? So here, we don't have that flexibility. If you decrement 3000, you go to 2999, right? This 2999 is not a part of a stack. So what we do is, in keeping this stack within the limits of the stack, in performing the operation within the limits of the stack, we need to check with a if condition. How are you going to perform a push operation here? Push operation is first decrement the stack pointer. At the decremented value, we are going to perform push. That is, data register contents will get transferred to memory of the stack pointer. Okay. So now, when you perform SP is equal to SP minus 1, SP minus 1, every time you need to check if SP equal to 2999. If SP equal to 2999. If SP equal to 2999, that means that it is crossing the boundary, right? And then we need to ensure that SP should be equal to the desired location, that is 4001. After 3000, where should we come? After 3000, we should come back to 4001. So SP must be equal to 4001. So every time before you perform the push operation, as we decrementing the stack pointer in this case, we should check with if SP crosses its boundaries. If SP crosses its boundaries, just get stack pointer back to the desired location where you want to push. Similarly, another if condition will be checked here also. After decrementing, are you coming back exactly here or going anywhere? So you can, being a designer, you will have to write an if condition to keep the stack within the vicinity of the stack. Okay, so this is how you're going to maintain the stack operations confined to the stack itself. Okay, now let us understand clearly this concept of upward stack and downward stack, because so far you don't know about push operation decrementing the stack pointer, right? Push operation never decremented a stack pointer in your programs, did it? No. Your teachers or your faculty members always told that push operation is going to increment the stack pointer. Just see how exactly it is going to be done. Okay, okay, this is one stack. Let us say this is another stack. Okay, let us see. Okay, this stack is arranged from 0 to 7. This stack is arranged from 7 to 0. This is the base of the stack in this one. This is the base of the stack in this one. Now tell me, in this stack, how the push operation is going to be performed? The push operation is going to be performed by decrementing the stack pointer. Push operation is going to be performed by incrementing the stack pointer. Okay, so this is called upward stack. This is called upward stack. This is called downward stack. Downward stack. What is upward stack? Upward stack increments the stack pointer during the push operation. What is downward stack? Downward stack decrements the stack pointer during a push operation. This is how the stack is going to be designed and implemented. Being a designer, you can choose anything, either downward stack or upward stack. But in main memory, we can't implement the upward stack. We have seen already this memory addressing conventions from top to bottom. But when we implement a stack, the stack must be implemented at the bottom place. So at that time, we use always downward stack. Okay. So being a designer, it is up to you which flavor of the stack needed to be implemented. Either it could be upward stack or it could be downward stack. But a stack is always a stack. A stack is going to serve as an excellent provision for various things in your programming language. As far as a programming guy is concerned, as far as a programmer is concerned, the stack is the best data structure for him. Why programmer considers the stack is the best data structure, you're going to understand in the next lectures. So this is all about stack. Just a small revision about the stack. There is a register stack. A register stack will get implemented in the CPU. Memory stack will get implemented in the main memory. Only the thing is, here in the register stack, this is upward stack because stack pointer goes in this direction, 0 to 15. Memory stack is a downward stack. It goes from 4001 to 3000. Okay, so that is the difference between register stack and memory stack. Other things like stack pointer shows the top of the stack in which there is an element present. Full and empty are 1-bit registers, which shows the status of the stack. If the stack is completely full, full will be equal to 1. If the stack is completely empty, empty will be equal to 1. Data register is going to provide the contents of the stack. When the content has to be pushed, we are going to collect it from the data register. If the content has to be popped out, we pop it and place it into the data register. That is all about stack. Okay.